Okay, adding and subtracting rational expressions. So like I said, first we're going to talk about rational expressions that have the same denominator. Second, rational expressions that have different denominators. We're going to do a very basic review to start out. Rational expressions are fractions, right? So I just want to remind you guys, if you're adding two fractions, if I have 3/4 plus 2/4, how do I do that? What do I do? Yeah, we just add the numerator. So this would be 5, and then the denominator stays the same, 5/4. Right? Subtracting is the same thing. So if I had 3/4 minus 2/4, that would be 1/4. Okay, what if we have different denominators? Let's say I have 5/6. 5/2 plus 1/3. Yeah, and how do I do that? Yeah, so I multiply this one by 3/3. And this one by 2/2. Very good. So I end up with 5 times 3 is 15 over 2 times 3 is 6 plus 1 times 2 is 2/6. So the answer to this would be 17/6. And then if I can reduce, I would reduce. Subtracting is the same process of multiplying by something over itself. So remember this, because this is something you know and you're probably pretty confident with it. When you start to see rational expressions with different denominators, it's the same thing. They just look a lot bigger and scarier. Even though they're not. They're really not. Okay, so let's say I have these two rational expressions, u plus 5v over 8v squared, u squared minus u minus 6v over 8v squared. The first thing we're going to look for, do we have the same denominator? Do we? Yes. Great. That's awesome. We want the same denominator. So all we're going to do is we're going to add, or in this case subtract, our numerators. So we have u plus 5v. Now we have to remember this is minus the entire numerator. So it's minus u minus 6v in parentheses. Or you can just right away, you could write minus u plus 6v. This negative sign applies to the u and to the 6v. All that is over just the denominator once, right? 8v squared u squared. That's it. So now in my numerator I need to combine like terms. I see a u and a minus u. So that's going to be 0u or just nothing. And then I have 5v plus 6v. So this would be 11v over 8v squared u squared. The last step is what we've been doing. We have to simplify that. So I have a v up top. That can cancel with one of my v's down bottom. My final answer is 11 over 8v u squared. So, yeah, so in this, let's do an excluded value. V cannot equal 0, right? It would be an excluded value for that. Yeah, some of these These are not really excluded value problems, but since we know that, it makes sense to kind of review it as we're doing these. But the way that some of these are set up is not to be excluded value problems. Right, and then the other one, I guess we would say u does not equal 0 because we can't have our denominator being 0. So just let's quickly kind of review what we did. We made sure we had the same denominator, right? We added our numerators, or in this case we subtracted, and we remembered to apply the subtraction to both things here. We canceled and reduced where we could cancel and reduce, and then we wrote our excluded values. Okay? That's the basic process. Let's try another one. What if I have x minus 5 over x squared? Okay. So this one's going to be a little different. The first step is the same. We have our same denominators. Sometimes you can actually reduce before you even add anything together. But that's not always going to be helpful. So, like what I want to point out here is, I could factor this, and I could say that this is x minus 5 squared. And then the temptation is to reduce the x minus 5 up here with the x minus 5 down here. But then I wouldn't have the same denominator anymore, so I couldn't add them together. Okay, so we want to kind of wait to reduce until after we've added the fractions together. So in this case, we have x minus 5 plus 2x plus 10 over x squared minus 10x plus 25. So now if I look at the top, x plus 2x is going to be 3x. And then minus 5 plus 10, I'm going to have 3x plus 5. So there's no longer anything that I can reduce there. There was in the beginning, but after I add them, there's nothing to reduce. Okay. I would still factor the bottom just to check to make sure. So in this case I know that it's x minus 5 squared. But there's nothing in common now between our numerator and our denominator. So we can't reduce. So we're done. Right? We know that x cannot be 5. That would make our denominator 5. So we could reduce here, but after we added, we can no longer reduce.
What if it's different denominators?
Yeah, so let's take a look at one that has different denominators. That's kind of the next level. So let's do this one. 7x over 2x minus x minus 2. Okay. So right away, I see 7x over 2x. I can reduce that x if I want to. Remember what I just said, that's not always going to be helpful. So I kind of want to look first at, what is my other denominator? 20x plus 16. And what I'm going to ask myself is x a factor of 20x plus 16? The answer is no, right? There's no way to get an x out of there. So in this case, I do want to reduce. I do want to cancel out my x's. Because it's going to make my denominators simpler. Now you don't have to do that. You could skip this first step that I did and just go straight to the next step. Now I'm going to treat these like two fractions with different denominators. I'm going to multiply this one times this denominator over itself. So 7 times 20x plus 16 over 2 times 20x plus 16. Then I'm going to multiply this fraction times this denominator. So I have x minus 2 times 2 over 20x plus 16. And I'm just going to put the 2 out front so that it looks like my first denominator. So now I have the same denominators. I'm going to add my numerators together. And there's a lot of, you could do this in many different orders. Like I could pull out a 4 from this 20x plus 16. If I wanted to do that, I could have done it even in this step. And in some cases, like if this had been an 8 instead of a 7, and I pulled out a 4 here, then I actually could have reduced that 4, right? Could have used that. So, again, these problems, you have to really kind of look at them and try to think of different angles. How might you simplify this? What could you pull out? What could you reduce? In this case, there's not really anything else we can do. So we're just going to go straight to kind of distributive property in the numerator because we have to combine our two numerators. I don't care about distributing the denominator because I don't have to add anything together. And so I actually want to leave the denominators factored. So in my denominator I have 2, I'm going to pull out that 4 now. 2 times 4 times 5x plus 4. Yeah, you could call that 8 if you wanted to. There's a lot of different approaches to this. I like to kind of leave things factored just because it helps me see what to reduce. And then in the top, I'm going to do this all in one step. So over here I have 140x plus, and I'm just going to leave this because to me it's easier. Like I said, you could multiply that out. You could have left 7 times 20 here, whatever you want to do. So plus 16 times 7 minus, and we have 2x, and then remember the minus applies to this and to this, plus 4. So I just did kind of a lot of things in one step, so I'm just going to check that I did everything right. Here I had 7 times 20, which is 140x, and 7 times 16. Okay. Here I had 2x and minus 4. I subtracted the 2x, and I subtracted the minus 4 to get plus 4. So that looks okay to me. Now what I notice when I look at this is all of those terms have a 2 in them. And there's a 2 in my denominator. So I'm going to start by canceling 2 from everything. So I'm going to cross that out. I'm going to make that into a 70. I'm going to make this into an 8. This is one term. Remember, 16 times 7. 2x, I'm going to cancel the 2 out. And then plus 4 is going to become plus 2. So I cancel the 2 out of my denominator. And then in each term in the numerator, I cancel the 2. That's going to make it a little easier to add these things together. So let's rewrite that here. We have 70x plus I'm going to just write 56 now because I know 8 times 7 pretty well. Minus x and plus 2 over 4 times 5x plus 4. Okay, I don't see anything else right away that can be canceled. This x here is kind of getting in the way in some sense because there's no other factors other than x to that term. So I'm going to start to combine my like terms. I have 70x minus x and 56 plus 2. So that's going to become 69x plus 58 over 20. Oh, sorry, I don't want to.
You forgot the plus two. Oh,
Yeah, I added the 56 plus 2 to make 58. Okay. Now, we see if there's anything else we can reduce. If 58 and 69 have anything in common? I don't think so. They're 11 apart. And then 5x plus 4. So I think we're done. Let me just check to make sure I did this one right. Didn't mess anything up. This one is off of your homework. Some of these will be and some of them will not be. Phew. You got it right. I was a little worried there when there's nothing to reduce, but there's nothing to reduce. So here's our answer. And we could write our excluded values. X cannot equal negative 4 over 5. Because that would make this term in the denominator 0. Also, x cannot equal 0 because we canceled an x over x at the very beginning of this problem. Other than that, we never canceled out, we never reduced anything with an x in it. Right? Reducing this 2 doesn't affect the x. So these are going to be our excluded values. And that's it. Okay. So again, sometimes there will be things you'll get here and you'll see something else you can reduce. It's kind of a game, right? You have to play around with your numbers a little bit. There's not really one set procedure. For me, the easiest thing to do is to look as early as possible for things that can be reduced. Right? But again, the second problem that I showed you, if I had reduced that, in order to add it, I then would have had to re-multiply it out. So you're paying attention to the denominator, so there's that game of you want to have the same denominators. You're also paying attention to your factors and trying to see when something can be pulled out, like this 2 that we pulled out here. Right? There's not a right way to do it though, so in a way this process is kind of forgiving. If we hadn't seen the 2 here, we would have hopefully seen it here. We would have ended up with 138x plus 116 over 8 times 5x plus 4, and hopefully we would have said, oh, all of those have a 2, and we could have reduced the 2 there. That would have been totally fine as well. So it doesn't really matter the order you do things, you just have to really, I think neatness is really important in these problems, because you have to really make sure you're keeping track of each term and each factor in each step of each problem. I said a lot of eaches. So that's it. You saw the ones with like denominators, and now you've done one with unlike denominators. And that's it. Questions?